and welcome back to AGT STEM. Today we're going to be watching a video about Protactinium. I think I said it right. I'm not sure though. Anyway, let's hop to it.
Is one of the few elements that is more or less totally useless. Protactinium is an element which is actually much more interesting than I expected. The first interesting fact is that it is one of the elements whose existence was predicted by Mendeleev. You've probably all heard how Mendeleev predicted the existence of gallium and scandium because there were holes in his periodic table. And he also worked out that there was a hole between thorium and uranium where he felt there should be an element. Now, the reason that people don't make such a fuss about protactinium in the context of Mendeleev is that protactinium was only really tied down, discovered properly in 1918, well after the death of Mendeleev, whereas he was here to celebrate gallium and scandium, and that made him famous. The problem with protactinium is that it exists in a very, very small quantities in nature, and it is called protactinium. Originally it was called protoactinium because it decays by radioactivity to form actinium. Originally, because Mendeleev didn't know about these series, the lanthanides and actinides, he put protactinium here. So you would have, after actinium, you would have thorium, protactinium, and then uranium. And so he thought that the chemistry of protactinium would be similar to that of tantalum. And it turns out that it is quite similar, and that was how it was isolated. The chemical problem is that when people were looking at ores, these are the minerals that contain metals, the ores of uranium, there was some radioactivity which suggested that there may be another element which could decay by emission of an alpha particle, helium nucleus, to make actinium. So it would jump 2 spaces to the left to make actinium, and the atomic number would go down by 2. The problem was how to isolate this material, radioactive element, from all the other radioactive elements that are found in minerals with uranium. And as you probably know, that radium and polonium have also been isolated from these minerals, so there's a real mixture. And it was the Austrian chemist physicist Lise Meitner, working in the institute together with Otto Hahn, who eventually in 1918 found a chemical way of precipitating the elements of this group, and at the same time as she precipitated those, the protactinium was also precipitated because its chemistry was similar, and she found some sign of the radioactivity in that material that she precipitated, and that was deemed to be the discovery of protactinium, and it was published in 1918. They proposed the name protoactinium. Everybody found it difficult to say protoactinium, so it quickly got contracted to...
Well, that's nice, but what's wrong with protoactinium? It's not that hard to say. Protactinium, protoactinium, they sound very similar. You cannot tell me that they don't sound similar. I don't see the big difference, but whatever. I don't get to name all the elements.
Protactinium.
That's not easy to say either.
No, but it's easier than protoactinium. All the elements above lead in the periodic table have a degree of radioactivity. So if we had a lump of protactinium here, it would be extremely dangerous in terms of its radioactive decay. The isotope, that's the particular form of protactinium that was discovered by Lise Meitner, had a half-life of, I think, 32,000 years. A few years earlier, the chemist Fajans discovered an isotope that had a half-life of only 1.5 minutes, which was so short-lived, he called it the name brevium, big for brief, so it's brevium. And so that, in a way, was the first discovery of protactinium. But it turns out that there is a custom that if several different isotopes of an element are discovered, whoever discovers the longest-lived isotope wins, and they're deemed the discoverer. There are two other parts, aspects I think interesting about protactinium. The first one is, just like Mendeleev said, it does form an oxide, Pa2O5. In fact, this is its most stable compound. The second thing, which is perhaps a more interesting fact for those of you who are real nerds for the periodic table, is that it is one of the occasions where the atomic weight of the element, you can see here 231 point something, is lower than the atomic weight of the element before it. There's another quite well-known pair here that potassium at 39 is slightly lighter than argon, which is the element that precedes it. So these inverted pairs meant that, unfortunately, Mendeleev predicted the wrong atomic weight for protactinium. It's 231, and he said it's 235, which is still not a bad guess. There was an attempt to make quite a large amount of it many years ago in the UK, where 60 tons of material were processed to make 125 grams of protactinium. And according to this book, the people paid $500,000 for the starting material, but they were only charging $3,000 a gram for what they made. So if you do quick maths, you can see even before you count in the labour, they made a loss on the material.
Why were they making it then?
I have no idea. It is used for the dating of sediments at the bottom of the ocean. People measure the ratio of the isotopes of protactinium and thorium, and from the value of this ratio, they can tell approximately how old the sediment is at the bottom of the sea. So you can argue whether or not that is really a use. It is more perhaps an application than a use.
Well, that was a nice video. I still don't think protactinium is that hard to say. Protoactinium is a little bit more difficult, but it's still not that hard. Anyway, thank you so much for watching. I'll see you next time. Stay smart. Bye.